Okay, so starting out with vocabulary you're probably familiar with, parallel lines as shown right here. Parallel lines go on forever and ever. They never intersect because they are parallel. If we were to abbreviate this, we could say that line JK is parallel to line LM. And parallel lines are coplanar. They're on the same plane, and they never intersect. And then next, skew lines. Skew lines never intersect. They are on different planes, so they would never run into each other. They are not coplanar, and they do not intersect. And we'll see examples of this in the workbook. Parallel planes are exactly what they sound like. They're two planes that are parallel. So we can say that planes A and B are parallel. And they never intersect. And then next is like the word of the day. It's the word we'll probably use the most, and it's the word transversal. Transversal refers to the line that intersects with the parallel lines. So this pink line right here is the transversal. And it intersects two parallel lines. So another vocabulary word we need to know is interior and exterior. When we talk about interior in terms of parallel lines with the transversal, interior is this area here, interior. And then exterior, as you may predict, is the outside. Okay, so these words may or may not be familiar to you. I do believe it comes up in 8th grade. Consecutive interior angles are like this, angle 1 and angle 2. These angles here are consecutive, meaning they're right next to each other. They are on the interior of the parallel lines, and they have a relationship. These angles are supplementary. So we can say that angle 1 plus angle 2 equals 180 degrees. And if these are consecutive interior angles, then these are as well. So angle 3 and 4 are consecutive interior angles, and angle 3 plus angle 4 equals 180 degrees. The next is alternate exterior angles theorem. You gotta wait, bud. Alternate exterior angles here, 1 and 2. They're alternate, meaning alternating sides of the transversal, and they are on the exterior. In this case, their measures are equal. So angle 1 equals the measure of angle 2. And then 3 and 4 alternate exterior angles as well. So here angle 3 is also equal to angle 4. So here's how you would use this, and this starts going into tomorrow's lesson as well. But if you knew the angle measure of angle 3, then you also know the angle measure of angle 4 because they're alternate exterior angles, and that's where the theorem comes into play. So the next one is alternate interior angles. So here we have 1 and 2. Alternate sides of the transversal, and they're on the interior. Alternate interior angles are equal. The measure of angle 1 equals the measure of angle 2. And here 3 and 4 are also alternate interior angles, so angle 3 is equal to angle 4. Corresponding angles, it doesn't have the vocabulary that helps you with it, but here's what corresponding angles are. So let's say 1 and 2. These are corresponding angles, and corresponding angles have the same measure. So angle 1 is equal to the measure of angle 2. Then 3 and 4 are corresponding as well, and the measure of angle 3 is equal to the measure of angle 4. Then these are also corresponding, so 5 and 6 are corresponding. Again, the measure is equal. And then, last but not least, 7 and 8 are corresponding. So today we're focusing on the vocabulary side of things. Tomorrow we'll focus on the actual math of it. Then right here we have perpendicular transversal theorem. What this theorem states is if your transversal is perpendicular to one of your parallel lines, then it has to be perpendicular to the second one as well. No, you gotta wait till we're done with the workbook. Okay, so now we're going to transition over to the workbook. It's 3-1 where we're going to practice using the vocabulary.